Hi, good morning everyone. I am Dr. Zhong here from FKE. I'm a lecturer of the subject of ODE, Ordinary Differential Equation. And this is the first chapter, first order ODE. In this chapter, you will study about the separation of variables, or linear differential equation, exact equation, and power series method. Now let's look at the introduction on the differential equation. What is differential equation? A differential equation is an equation that contains a derivative of an unknown function. So you have two types of differential equation, that is the ordinary and partial. So ordinary is if all derivatives are respect to single independent variables. For example, dy over dx. So this is the first order, or second order, d squared y over dx squared. So it's the first order, second order, or you can have the third order or the fourth order. If third order and fourth order, then you can have the d power of 3y over dx power of 3. So this is the third order. Okay, you can write the differential equation in this form or is in another form. That is the y prime, y double prime, y triple prime. So that is the how you write the differential equation. And then the partial type of the differential equation. What is partial type? Partial type is derivative with respect to two or more independent variables, such as du over dx or du over dy, or d square u over dx dy. Okay, or we don't say it's a d, it's a del u over del x, del u over del y, and del square u over del x del y. So this is not only a single independent variables. So this is two. Okay, two independent variables. We have the x and y. Okay, but in this subject, you will only study about the ODE, only the single independent variables. Apart from type of the differential equation, you also have the order of differential equation. Okay, so just now I already told you, you have first order, second order, third order. Okay, let's look at what is the difference. Okay, if you have the first order, you have dy over dx, and then if your second order is dy squared over dx squared, d squared, and yeah, and then if your third order is d squared and d power of 3 over y, d power of 3y over dx power of 3. So this is the third order. You refer to the value here. Okay, and then this is ODE. Okay, or the example of the ODE for the first, second, and third. But what about the partial? Okay, if you look at here, there's a del square u. Okay, this one is a second order. This one also the same, del square u, and then over the del x squared. So this is second order again, and this one also second order. And then this one don't have the. This one only have del x, del z over del x. So this is the first order. Now let's look at the example. Determine whether the following equation is an ordinary or partial differential equation. So for each differential equation, write down the order of differential equation. So now let's look at the first one. This is what? D squared y over dx squared. So this is the second order ODE. What about this one? Okay, it's a y double prime. So when you see the y double prime, it is a second order. Okay, so this is d x d square y over dx square. So this again is a second order ODE. This one is the partial. Okay, del y. So this is the first order partial differential equation. This one, This one not even the dy over dx. So this is not an differential equation, just an x squared plus y squared. So this is not an differential equation. Then what about this one? Y power of 4. Okay. This is y power of 4. So this is fourth order ODE. Okay, this is a fourth order ODE. Next, we look at another example on obtain an ordinary differential equation from the expression of y equal to 2x power of minus 2x plus a over x squared. Okay, now let's look at how we solve this question. Okay, we have this expression, and then we rewrite the expression of y here. So you get 2 exponent negative 2x plus a exponent negative power of negative 2. So to bring up the x power of 2. And then you differentiate the y. So you get dy over dx is equal to negative 4 exponent negative 2x minus 2a exponent 2ax power of negative 3. Okay, and then what equivalent to negative 4 exponent negative 2x minus 2a divided by x power of 3, right? Okay, now what is a here? Okay, from the equation here, we know that y is equal to 2 exponent negative 2x plus a over x squared. So can you rearrange it by writing the constant a? So a from here, a is equal to y. Okay, you bring the y minus 2 exponent negative 2x. So you bring this part to the left hand side. Y minus 2 exponent negative 2x x squared. Okay, so this is a. So the a here, later you need to substitute the value of a. Okay, now we substitute the value of a. Okay, we substitute the value of a, and then we simplify it. Minus 2y over x, because you have the x power of 2, you cancel out x power of 2, you still have only one x left, and then plus negative is positive, so plus with 2 times 2 is 4, so 4 exponent negative 2x divided by x. So now you can take out the variable. That is equivalent to negative 4 exponent negative 2x. Okay. 1 minus 1 over x minus with 2y over x. So class, can you tell me what is the order of the differential equation? Can you tell me? This is the first order because it's a dy over dx. So the answer is this one. Okay, so this is the first order of the differential equation. You understand now? Next, we go to another example. Obtain an ordinary differential equation from the expression a y equal to a exponent x plus bx by eliminating the constant. Okay. So now you have the question like this. Okay. So can you take out the variable, can you rearrange and write a constant a is an equation? Okay, let's look it together. B equal to y minus, okay, we want to take this b, right? So b equal to y minus a exponent x divided by x. So this is the equation for the constant b. Okay, we name it as the equation 1. Okay, now you have y, right? So what is dy over dx? You differentiate the equation of y. So you differentiate, what do you get? A exponent x plus b, right? Okay, and we name it as equation 2. Okay, you differentiate again. So this is a second order, d square y over dx squared. Then you get, what do you get? You differentiate this one, you get a exponent x. Okay, now what is the equation if I want to take this a as a equation? So a is equal to d square y over dx square, and then divide by exponent x. Okay, and we name it as the equation 3. So now I have equation 1, 2, 3. You have a and b. So now I want to insert the equation 1 and 3, which means the a and b, into the equation 2. Equation 2 is this one. Equation 2 is this one. Okay, you want to insert the constant a and constant b into this differential equation, first order. What do you get? dy over dx equal to dxy over dx square and then you have exponent x equal to a. A is what? A exponent x, okay, plus b. So this is plus with b. B is y minus a. Okay. Divided by x. So after you simplify, so this one and this one can cancel out. So you left d square y over dx square plus with y over x minus with 1 over x d square y over dx squared, because this one also can cancel out. Now you can rewrite the equation or rearrange the equation. Rearrange the equation. Okay, you have dy over dx, and then d square y d. So this is the first order, this is the second order. So you rearrange. So you bring this one to the left hand side. So you have d square y over dx square, and then you have the plus with 1 over x d square y over dx square plus with dy over dx minus y over x equal to 0. And then since this one is divided by x, so I multiply with x, so you have the value of You multiply with x, so you have negative x d square y. Then plus with d square dx square. And then plus with x dy over dx minus with y equal to 0. So this is the second order of the differential equation. Okay, class, do you understand? For the second question, can you do it on your own? And then the question is, the answer will be the answer of example 1.3. Question B. The answer is y prime double prime equal to negative 4y. Okay, so before this, there is a negative 4a sine bx minus b cos bx. That is equivalent to negative 4y. Okay, you can try on your own. If you have any question, you can contact me. Next is the solution of ODE. What is meant by solution of ODE? A function is a solution of an ODE if it satisfies differential equation, which makes the equation left equal to equation right. The left hand side equal to right hand side. Okay, so later I will give you another example to show that the function is the solution of another differential equation. Okay, let's look at example. Show that the function of y equal to a plus bx exponent to x is a solution of ODE or a differential equation of y double prime to y double prime minus 4y prime plus 4y equals 0. Okay, so you have this question. Y equal to a plus bx in the bracket exponent to x. So you multiply in the exponent here to the a and to the bx. So you have the a exponent to x plus b, so this one, b x exponent to x. So this is the equation of y. So after you have equation of y, you need to differentiate. Because of what? Because the question asks you to show the function of y here is a solution of the ordinary differential equation y double prime minus 4y prime plus 4y equals 0. This means that you need to find out what is the y double prime and y prime. And then after you find out the y prime and y double prime, you need to substitute in the equation here. And then you need to prove that. Okay, so now you have the y here. Okay, then you need to find out the y prime. Okay, differentiate the y, you get the y prime. Okay, so you need to differentiate this equation. If you look at here, this is 2x here. Bx exponent to x, so you cannot differentiate directly. So you need to use the product rule. Okay, if you need to use the product rule. This product rule is y equal to uv. Then dy over dx is uv prime plus with vu prime. So what is u, what is v? So I already determined for you. The u is, I assume, is bx, and v is exponent to x. So when you assume u equal to bx, du dx is b, right? And v is exponent to x. dv over dx is 2 exponent to x. Okay, can you follow? Now you have the u and v, then you can use this formula. U dv over dx plus v du over dx. So you substitute the u is bx, dv over dx is 2 exponent to x, and then plus with the v. V is exponent to x, and then du over dx is b. Okay, it's here. So you get the first order dy over dx equal to this one. Now, you need to differentiate again to get the second order. Okay, so just now, this dy over dx just for this part. So you need to substitute in, okay? You need to substitute in. So this is the first order y prime is 2a exponent to x, and then plus with this one. So this is the whole things for the first order. And then after first order, you do the second order. You do the second order. Okay, you differentiate these whole things. Again, you have this 2x here. You cannot directly. Again, you assume the u is bx. Okay, then du dx you get b. V is 2 exponent to x. dv dx is 4 exponent to x. So you substitute in this one. The same method like just now I told you the formula. U dv dx plus v du dx. You substitute in this part. That is why you get bx is u dv dx is 4 exponent to x, and then plus with v is 2 exponent to s, du dx is b. Okay, we get this one. And then this is for this part. So now you can differentiate the other part. That is differentiate this one, you get 4a exponent to x. Okay, you differentiate this part, you get this one. And you differentiate b exponent to x, you get 2b exponent to x. So now you can sum up this one. 2b exponent to x, this also 2b exponent to x. So you sum up that one, you get 4b exponent to x. This one also you can factorize it. 4a plus 4b equal in the bracket exponent to x, or you can have a plus bx in the bracket 4 exponent to x. So don't forget you have the x here, so that's why you have the bx. So a plus bx multiplied with 4 exponent to x. And now you have the second order, you have the first order, you can substitute in the equation like just now I told you. Okay, so left hand side is equal to the right hand side, right? So you substitute the y double prime, these whole things, okay, to here minus the y prime, 4y prime. So for y prime you get is this one. So you substitute everything here plus with 4y. 4y, y is from the equation a plus bx exponent to x. So when you sum everything up, is equivalent to 0, which is satisfies the definition of the solution of ODE. Okay, so left hand side is same as the right hand side. So that's all for the introduction of the ordinary differential equation. Hope you can understand and enjoy my video. Thank you very much. Then thank you for watching.